Hey everybody, this is Larry, this is me going Q3 of the weekly contest 438. Check if digits are equal in string after operations 2. Hit the like button, the subscribe button, join me on Discord, let me know what you think about this one. So I ended up taking a long time on this, well I didn't solve this one, but I ended up taking a long time before skipping the Q4. Not really happy with this one. Frankly, it is not a good problem. Relatively certain that it is not a good problem, and the reason why I say that is because the solution apparently is very Googleable, which is bad enough, but also if you don't know the solution, it is possibly very hard to do. I was trying to so the TLDR is that the easy way to do it, if you know, it's called this thing called Lucas theorem. I think you could Google this. Yeah, it is for it is just a thing for solving this problem. But stepping back a second, the reason why I don't like it, and I think this is a bad problem, is because, like I said, it doesn't test anything. It tests whether you know this theorem or not. For the most people, like if you're really good, you could grind it out, right? But yeah, if you know it, then you pass this one. If you don't, you don't. And now, except you have even more, right? Because you can. This is a Googleable thing. So then now you have people who are Googling doing better than people who are not, and it's not even close, right? And there's nothing on top of it that's really different or tricky. It is just literally that. So I don't know. I think it's a very crappy problem as a result, especially as a Q3. And I say that because I was able to get Q4, but then it just becomes a problem of, well, how long do you spend on Q4? Or sorry, how long you spend on Q3, right? Because if I could have given up Q3 earlier and got a better score for Q4, which lowers my finishing time, which is really silly, right? Like this, I don't know. I just think it's a very silly problem as a result. But let's go over it. I think there are two ways, at least two ways, but two main ways that I'm going to go over. But not even in that much details, frankly. Right? Only because I don't know this one that well. I did honestly know this, but I was really hoping to figure out something from first principles. I honestly did expect it, or was hoping anyway, Leetcode, like there was another more basic first principle solution and not just a copy and paste from Google solution. That, you know, I was hoping that was the case, and as a result, I was trying to figure out that more basic solution. Turns out there is kind of that solution, but it was very hard, which is fine. But if there's no existence of people just ChatGPT and Googling, then maybe I would have a different feeling about it. But then it's still a crappy Q3 anyway, because it makes it so that if no one's solving Q3, then your Q4 score is not a really good Q4 score, because it's just how much time did you spend sitting on Q3 before you give up score, right? Anyway, let's actually focus on this problem, right? So I think the first thing to realize is that okay, I mean there's this thing, but it's a part of it, but it's not the whole part of it, right? So there are a couple of things you have to realize is that, okay, so yeah, you have this number, right? Right? I added a couple of digits, but then the idea here is that yeah, you combine these two, and these two, and then you become a little bit smaller. So the way that I would think about it is actually, I was trying to draw this out, or I was trying to ask you all this out, but actually let me not, and let me actually use a paint thing so that it's a little bit easier. Hang on, technology is tough. Okay, I think this is on, right? Okay. But yeah, but basically the idea here is that, okay, so let's say you have, you know, a couple of numbers, and then the idea is that, okay, you add these two, right? So then you have some number here, it's 2, 4, 7, right? And then 6, 1, and then I guess you just compare, right? And then, but you can kind of go backwards a little bit, right? There are a couple of ways you can think about this, but the way that I would think about it is go backwards. So let me use a different color, actually. So if you mark this as 1, the contribution is 1 because everything's just going to be a multiplication of that. Then that means that this has a contribution of these two, and that means that these two has a contribution of 1, 2, and 1, because this is the sum of these two numbers. And yeah, and if you kind of write it out a little bit more, right? So that's basically the idea. Let me slow down a second. I probably went by this a little bit fast. What I mean by that is that this final answer, if you want to get from this row to this row, then it is just the final answer of, well, this 3 contributes to the final answer 1 time, this contributed 2 times, this contributed 1 time, right? Because you can't draw it out. And in fact, so then you have 1, 2, 1, right? It's going to be 1 times 3, 2 times 9, plus 1 times 5, and that is what? 3, 18, 5, and that's going to be 6, right? Okay. Yeah, so that, I mean, I modded by 10, by the way. But yeah, but that's basically the idea behind this one, right? And then once you draw it out, so then now it becomes, well, we know these numbers. Oh, I didn't highlight it correctly. We know these numbers. We know these numbers. All right, they're the initial input, and they change with different input, right? But the rest does not. And what I mean by that is that you kind of want to draw it out from the bottom, or I guess top maybe. I don't know. I like to draw these from the bottom. So you start with 1, and then it has contribution from these two numbers, and then this one has contribution from this one has contribution to right? I don't know why I drew so close to the left, but here you can kind of see, yeah, right? If you kind of look at it backwards, then, yeah, this is going to be 1. This one is going to be these two, so then that's going to be a 3, 3, 1, right? And then you have 1, 4, 6, 4, 1. And it doesn't take much to recognize that this is, of course, Pascal's triangle, right? And the way to kind of calculate any given point is, of course, with combinations, choice, right? So you can say, for example, this if you have 5 numbers here, or if you have 4 numbers, sorry, this is going to let me change the color. This is going to be 4 choose 0. This is 4 choose 1. This is 4 choose 2, right? And 4 choose 3, and 4 choose 4, right? So okay, so that's basically the idea, or that's the initial part of this problem, right? Because then now, if we're able to get these rates, then we can just multiply them, or not we multiply and then sum it with the original array, right? And we'll be fine. The problem is that there are, for any given cell, and by cell I mean these circles, for any given circles, there are 2 main ways that I would think about it, right? One is, of course, to construct what we just did with Pascal's triangle, 1 at a time. However, n in this case is 10 to the 5th, and here you're gonna, on the row 10 to the 5th, there's going to be 10 to the 5th square cells, right? And that is going to be, ooh, what happened? What is going on with my thingy? Is this better? Nope. Okay. That's going to be 10 to the 10. That's just too big, right? Okay. So then the other one is that you have n factorial over c factorial, I guess k, sorry. K factorial, and then n minus k factorial, right? So that's the other way to get this. The problem is that we only care about the last digit. I mean, even if you care, well, you can't care about all the digits, right? Because, well, n is going to be 10 to the 5th. So on the top, this is going to be a very big number, right? Because there's 6 digits each, say, and 6 digits times 6 digits is going to make 12 digits, and then so forth. So that means that you're going to have, if you just calculate the math for storage, it's just too big, or if it's not, it's just too long, right? Because you're multiplying 2 12-digit numbers, it's going to take 24 operations. I know there's like Kawabaschi multiplication and stuff like that, but roughly speaking, you know, multiplying 2 big int is going to be very expensive, right? So yeah, so you can really do this. So then the idea here is then what do we do? Well, what we do is apparently Lucas algorithm, which is why this is annoying. And Lucas algorithm, I'm not gonna lie, I'm not gonna show you the proof. This is just silly, right? I mean, you can read up on Wikipedia itself, but the short answer is that this is the algorithm. And the algorithm is just that for any p where p is a prime, you just take the product of every digit. Yeah, I mean, which is the way I would say it. This looks a little bit awkward, but we'll go over one example real quick, or maybe two examples. A couple of examples. Not committing to number of examples. Okay, and what I mean by that is that, so let's say p is equal to 5, right? Then now I don't know, maybe you have a number that's like 892 or something, right? So n is equal to 892. So then now, and k is equal to, I don't know, let's just keep it easy for me to do the math, which is 5, right? So then now, and this is base 10, and this is very terrible handwriting, which is why I don't do this that much. Yeah. So n is equal to 892, say, and k is equal to, say, 5, just to make my life a little bit easier. But then now, so you convert this to base 5. Actually, I'm just going to use a calculator. Hang on. Okay, base 5. Sorry, friends, technical difficulty. Right, put in the wrong number. Difficulty, hang on. From decimal to base 5. Just tell me the answer. Okay, 12032. It was trying to do the math for me, or like show me the work, and I'm like, I don't care. Right, so that's the number in base 5. This is of course 10 in base 5, right? So basically now you do it one digit at a time, where this is 2 choose 0. Yeah, 2 choose 0, 3 choose 1, 0 choose 0, I guess, and yeah. So that's basically the idea, is then you take all these products and then you mod it by 5, and then you kind of get the answer mod 5. How does it help us with 10? Well, the thing with 10 is that, well, 10 is equal to 2 times 5, so you have 2 primes component. And then as a result of that, you can use the Chinese remainder theorem to calculate it. I know that my explanation is not very long or in-depth, but frankly, this problem is crap. So I don't know. Is there a good point? I don't know. Like, you can spend time to learn more about the proofs and stuff, like it's on this Wikipedia article. I'm not going to learn this. Why? Maybe if it comes up like 4 or 5 times or something, maybe I'll learn it. I mean, I'll probably know to do it next time, just because this time, frankly, I thought there may be a similar solution. But if there's, if it comes up again, at least I know to look for it and actually do it. Because I knew of it, but I was a little bit wonky on the details. But also, I just thought there'll be a more first principle solution or something like that, like a simpler solution. It is what it is, right? But yeah, and again, I didn't expect to see it this time, so I don't know that, like, if you're studying for interviews, I wouldn't care about it. And yeah, maybe it's just one off and then you won't ever see it again. There are definitely algorithms in Leetcode where you just see it once and never see it again, right? So yeah, I don't know. It is what it is. So is it worth your time unless you're really, really good? I don't know. It's not, I don't even think it's worth my time, to be frank. So that's just me explaining it to you, right? Anyway, yeah. So that's basically the idea, and everything else is just to facilitate how to calculate that. So definitely, if my really brief overview of Lucas' algorithm is not good, pause at this point and just go over it. I'm gonna go over my implementation, which I think is cleaner than a lot of people's solution. I mean, I did this after the contest, so it's easier to say that. There is a couple more optimizations that I can make, but yeah, actually maybe it's not that clean, but either way, yeah. Okay, so first of all, on the optimization, the thing that I noticed is that for Lucas's algorithm, you're always going to choose one digit in that base at a time, right? Well, what does a digit in that base mean? Well, for base 5, it means that every digit will be just 0, 1, 2, 3, 4, right? So that means that we can brute force everything, right? Because for 5, there are only 5 numbers on top and 5 numbers on the bottom. That's 25. And you could do even better because half of those numbers where the top is smaller than the bottom, that's just 0 because that's just not possible, right? So, okay. So yeah, so we put everything for P5 in this one. We do the same thing for 2, right? And keeping in mind that, like I said, it's every possible digits of 5 in base 5 and every possible of base 2, which is binary, which is 0 and 1, right? So okay, so that's basically my things. And then lookup is actually, I mean, you may recall Chinese remainder theorem, or sometimes known as, well, I mean, not known as, it's just shortened as CRT, right? Yeah, and if you know that, that's fine. You could do it that way. But keeping in mind that this is only 2 and 5, which means they're really only, well, there are only 10 possible values, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and all of them are unique because that's just how Chinese remainders theorem work. And as a result, you can just write a lookup because there's only 10 numbers. So yeah, so here's the 2 remainder and the 5 remainder, and then that will give you the answer. And that's really it for the setup. And then now everything is just what we said about Lucas. Yeah, there was actually a little bit of an optimization we can even do, right? So okay, so well, first of all, I separate them out because I didn't worry about it that much. But yeah, but left we go, okay, well, we calculate the we calculate the remainder with its 2, we calculate the remainder of its 5, and then the lookup will give us the reverse the last digit of the reverse number, and then we just times it by the input on the left side. We do the same thing for the right side, and then that's it. And this part is the Lucas algorithm, right? Yeah, it's just n and k and a given prime, even though I did an if statement, so maybe I could have done this a little bit differently. But in any case, yeah, so we do it a digit at a time, keeping in mind that if one of these things is 0, then that means that yeah, that means that we're done, right? So that's why, because, well, if n is 0 on top, actually I don't think it can be, or actually it may be, but in that case we just returned 0 already, and as a result, yeah, we should be good, right? So here we take the digit, the last digit in base P, right? So if this is 5, then this is the last digit, and I just T and B mean top and bottom for the choice. And yeah, if top is smaller than bottom, then R0 is 0 and we return it early. Otherwise, we just look it up in the lookup table as we said. And yeah, and this will get us the rates. And that's it, just one digit at a time. This is literally the Lucas algorithm, maybe with some minor optimization. And that's really it. I think the only thing that I could have done is that I do double count this, which makes it slightly expensive, but we can also just slap a cache on top. Of course, you have to clear the cache. Maybe, I think. Otherwise, maybe it gets expensive. But yeah, so you can even do that, right? And let's just take a look at the thing. Yeah, so adding the cache brings it down from 4 seconds to 3 seconds. Not so. I don't know. So it's just a duplicate work. Yeah. But that's it. This is the left side. This is the right side. Keeping in mind that, you know, just we keep track of this. Yeah, I don't know why. Actually, I don't even need the cache. I could have just written it this way, right? I am being silly. Okay. So we don't need the cache. I am just being silly. But yeah, I'm just curious how much faster it is. That's why. Yeah, I mean, okay. I guess the cache part does most of the work. There's a little bit better, but not by that much. And that's really it for this one in terms of the Lucas idea. Again, you can pre-calculate all of this, right? I mean, this is 5 square, this is 2 square, this is O of 10. So like, you know, I put it on the outside, but you can put it inside. It's not a big deal. Yeah, the other way that I was trying to, so the way that I was trying to get to work is how PKU error 10. So I'm looking at his code now. Let me actually put it here so that it's slightly easier to read. Is the idea that, okay, the idea for this solution, and it's the way that I was trying to work out but I couldn't figure out, which is that, what is it? C of n of k is just equal to C of n k minus 1 times, I think times k divided by n minus k minus 1, or is either this or the other way around? I guess the first half it is going to be, I don't know, it depends how you do the loop, but something like this, right? And as a result, well, if you know the last digit here, you can figure out how to get the last digit here and then divide it by the last digit. That's basically the idea for this. And you just calculate it one at a time. And then well, that's one of the ideas. The other idea is just that you keep track of the yeah, you just keep track of the what is this? I don't know how actually this part works, but I think this is the core idea. The other thing is just counting the number of 2's and the 5's. The reason why you want to do the 2's and the 5's is so that we can subtract them out later. If they don't actually show this here, but yeah, for example, if the end result has, you know, I actually don't quite know how Actually, maybe it's not clear to me how this works. Maybe I'm wrong on this one. But I think that is the general idea. You usually want to keep track of the 2's and the 5's. So that it allows you to kind of figure out the last digit is all. Keeping in mind that yeah, so you kind of keep track of the last 2 and the last 5, and then this allows you to kind of take it out, and then the last 2 and the last 5, you can kind of count the number of things. So then the TM would be you know, one of the, so basically the idea here is that, okay, well, C of n of k is actually equal to n factorial, which doesn't change, over some k factorial and n minus k factorial, which we talked about, right? And then the idea here is just keeping track of this, the left side and the right side independently, and then figuring out, yeah. And I guess and I guess this is like a transitional thing. Okay, maybe I lied. Maybe I don't. I thought that I understood this, but maybe I am lying. Because okay, I don't know what necessary to append means. I guess that's the number that we care about. Last v and the last 2 and last 5. Well, last 2 and last 5 is just the number of 2's and 5's that lives in here, and then the last v, I don't know, is just the current v factorial, I suppose. And then I guess the last of this is just that. Yeah, I'm not sure I understand this one, honestly. But I thought that it kind of based off this idea, and I mean, if I did, I would have gotten this during the contest, and I did not. So yeah, just to kind of give you a non-Lucas solution. Not that I understand this one too much, apparently. But yeah, that is all I have for this one, though. Let me know what you think. Thanks for watching, and let me actually before I go, show you my solution real quick. That's not it though. Yeah, so yeah, again, this is the top of the pre-calculating, And then here, this is actually Lucas' algorithm. And then here is just doing it one at a time with the lookup and then the left and the right. And yeah, that is all I have with this one. Let me know what you think. Let me make this smaller. Still can't really squeeze it in, but oh well. So this is the top and this is the bottom. And yeah, thanks for watching. And yeah, stay good, stay healthy, and you could watch me solve it live during the contest next. If it times out, that'll be a little bit sad, but I think that should be okay. Okay. We're doing okay. We have a 6-pointer and an 8-pointer. So let's see. After operations 2, okay. It's just that now it could be really big, so n squared is not good enough. For Q1, we did have an n squared solution, so yeah. Okay. One person gotten it. How about Q4? Also one person gotten it. Let's see. What does that look like? Contribution of the last thing, right? So it's just a sum of a lot of numbers. Right? So then now it is just Pascal triangle, right? Yeah, it's just Pascal triangles. Not that bad. Pascal triangle. It is n factorial over k factorial over n minus k factorial, right? Okay. So then it's just that, and then it's just doing the math with modular inverse. That's awkward, but fine. Okay. And then factorial is equal to 1 for the, and I guess we have to put it outside. I don't know why I did that, but yeah. Mod, it's mod 10, right? Yeah, I think mod 10 is fine. And then do, can I do mod 10? Is that right? I mean, it should be right, but okay. Let me verify this. If this is true, then you have 4. Then it goes to the triangle. Okay, let's write it out. Where to 4? You have 1. You have 2, right? And then now you have 1, 2, 1, and then 1, 2, 1 as well. Alright, so then now we're just checking whether this number, yeah, so it's just, so it is thing, but how do I do it with respect to mod 10 though? Because that's not, you can't do a modular inverse on that. You've done it. I mean, the idea is right, but I don't know how to do it necessarily. Yeah, okay. I guess it's just last digit math, right? I forget there's a last digit, so you can't do this. This is fine for the factorial, just number factors. So then you need the prime factorization of every number, which is, no you don't. You just need to count the number of 2's and 5's. Yes, okay. How do people get so fast? I mean, maybe they have libraries, I don't know. Okay. Okay, focus. And I think this is fine. But you still have to do the math, right? Okay, fine. How do I want to write it? Okay. Do I need it like that? I think so, maybe. I don't know. Okay, that's... Is that fine? Actually, because then you have the 2 and the 5's and the rest. But can you mod that? I don't know. People are getting it though, so is there a smarter way to do it? Let's see. Okay, so let's say if n is equal to actually, let me try something real quick. It doesn't make sense, right? Oh, wait, no, this isn't the last digit, right? This is the last digit. I'm thinking of the one problem. Okay, so if it's digit, then okay, let's... There's some math here. So, okay, so it becomes 10 for sure. Okay, so then what if n is equal to 10, right? Okay, so 5, and then now it becomes that, right? Is there a pattern here? So it's 1, 6, 15, and then 20. How do you determine this? Is there a better way to determine this? And is this even right, at least? How slow is... I think this might give me a string too long error, actually. Yeah. Is it fast, at least? I don't know. Oh, I shouldn't print it. Oh, well, it's too late. I mean, it's not fast, but... Oh, but you still have to loop it, right? So maybe if you do something like... just this... Like, that would be too slow already, so that's not that fast. So we have to sum that. I mean, even if you spell half of it. Yeah. So we can't do it that way. We have to be able to do it. Is that anyway? No, I want to put So okay, so well, so n choose 1 going to n choose 2 is going to be what? You times it by k, and then you divide it also by n minus k. Right, because n over 1 is going to be n minus 1 factorial, 1 factorial, and then going to 2 is going to be n factorial over 2 factorial, n minus 2 factorial. And what is the change? The change is that you multiply 2 and you divide it by an n minus 1. How do you do that? Yeah, I'm just bad at math, maybe. I mean, you can't do an n squared to calculate this, so that's the hard part. This is a problem where I had to skip. People are already done. What is that? Only 4 people got now. I feel like I should have I mean, I know the idea behind this one, but I don't know how to do the mod 10 part. Let's see. Is there another way of doing it? Do we need to know the math? Okay, maybe it's the delta. Maybe I don't need to know the math. Okay, so it's 1, 2, 1 minus 1, 2, 1, right? For 3, so that means that it has to be subtracted as equal to 2, right? That means that here, they don't really cancel out, right? So it's actually 1, 1, 1 is equal to 1, 1, 1. Okay. We can check that, right? So that means that is the sum of these 3 numbers, which is 2, these 3 numbers, which is 1. Well, that's wrong. Well, they're different. So it's basically, okay, so then that means that you have 1, 1, negative 1, negative 1 is equal to 0. That means that this is 12, this 2, this is 2, and that's good. All right, let's try another one. 1, 3, 3, 1, 1, 3, 3, 1, right? That means that you have 1, 2, 0, negative 2, 1 for 5 numbers. So that means that it is, but I don't know how to generalize this, right? So that's not, okay, so that means that 7 doesn't matter. You have 1 and 2, so that's 8, that's 11. Negative of this 16 plus 25, wait, what did I say? 8, so 11, 16 plus, well, I mean, this is a 4, so I guess that's why it doesn't work. Okay, so that's 1, 3, 3, 1, right? So what's 1, 4, was it 1, 4, 6, 4, 1 or something? 1, 4, 6, 4, 1. We subtract, it's 1, 3, 2, negative 2, 3, negative 3, negative 1. But that's the thing, right? Is that you still need the binomials then, right? Like, I don't. Okay, let's see. I don't know how to get the last digit on this one. People do apparently. So let's see if I can see a pattern maybe. Because it's not just that, but okay. So that means that okay. So let's just say we print. Right, so here let's just say 6, right? Okay, I mean I shoved in a, okay, that looks like a 6. Well, 6 has 7 numbers, which is I guess right, but so 6 includes, but okay. So then now we want this to subtract by oh, that's why, because it's off by 1. So actually it's this minus I plus 1, maybe. So then on 6, no, this is, it should be I minus 1 maybe. It doesn't count the first one, I suppose. So okay, so okay, so current is equal to, yeah. It feels like it's not necessarily an easy one, but it shouldn't, I don't know, it feels like it's a knowledge one, and I don't know if I know that thing, and maybe I should have done the next one, I don't know. If I don't see a pattern here, then I'm gonna do, okay, so 6, let's just do some, okay. Okay, I mean that looks more right, except I have to do a 1 at the end, but that's fine. Alright, so that's okay, and confirming the things that I did manually. 3 is 1, 3, negative 1, negative 1, so that's for 2, for 4 numbers, right? So for 4 it should be 1, 2, negative 2, am I off by 1? For 5 numbers, oh, for 5 numbers this is right, yeah. No, I'm off by 1 somewhere. 1, 3, 3, 1. This is very awkward actually. It's always a 0 somehow. That doesn't seem right. So I think I'm off by a little bit. But I'm just want to see a pattern. This should be, so 4. You have 3 numbers. That means that you want 1, 2, 1, 1, 2, 1, right? 1, 2, 3. Choose 0. Is 3. Am I just off by 1 and I'm dumb? I mean, maybe. Why am I so bad at this? The 4 numbers, you want 1, 2, 1, right? Okay, let's ignore this for now. That's wrong, that's why, but so 4 numbers, this makes sense, but we actually don't want that. We want For 4 numbers, we want n minus. I'm just really bad at this, I think. Okay, so you have 1, 2, 1, and then now. Okay. This is more right. I mean, kind of the last digit because of this thing of the last number, but something like that. Okay, maybe it's a little bit wrong. I can't even get this right. What is wrong with me? What I want is just 1, 2, 1 minus 1, 2, 1, but off shift, right? Alright, whatever. I can't even write dumb code correctly. I'm having a rough day. I think this has always been a rough day these days. Alright, 1, 2, 1, okay. Yeah, and just right? Alright. So then now we want to subtract this from, yeah, right? So then, right? Press enter, say, right? And enter that append 0, and then whatever, enter 2. I'm just being really dumb. Alright. Alright, now we're able to see what we okay, now we're able to see what the thing. Okay, so that's 4. What does 5 look like? Yeah, okay. Is there a pattern? Let's see. Alright. Maybe I should print n here. It doesn't matter that much. Okay, so 9. I don't know. Like, this doesn't. I mean, I know that's symmetric. That's a easy pattern to see, but I don't know that there's a easy thing, right? Like, basically, this has to sum to 0, which is fine, but how would you Catalan triangles? Okay, but I mean, I don't know how to do this. I'm missing some. I mean, is it just like mod 2, mod 5 or something? I don't know, but you can't just do division that way. I don't know how to do an modular inverse of these things. I don't know, maybe 153. Maybe I just suck at programming these days. But we can't even do math.com that big, right? So we need something funky like this. Even though, I mean, I have the idea, I just don't know how to do it. Spent so much time on this problem. What a silly contest. I mean, is there another way? I mean, I don't know. I don't see a pattern for this one, huh? And this gets pretty big pretty quickly. I mean, and no real pattern that I could tell. I mean, there are a lot of zeros and fives, but that doesn't even help me enough because you divide it by zeros and five by powers of 10. So how do 200 people get this one? Am I just that out of shape? And I have this one just in case, but I mean, what else am I thinking that I'm not doing other than I mean, yeah, to generate this, I need this anyway. So this is, both of these are kind of not that useful. I was hoping that it kind of, a lot of things canceled out in a way that I can figure out, but clearly that's not really the case that I can tell. So that's not really useful. I gotta stop doing these contests. I don't know how to do anything. 34 people got in that one. Should I have spent that time? 200 people got this though. I don't know how I'm messing this up. I mean, yeah, I don't know how else to think about this. I was going to test something funky, but is there another way to think about this? what do we use big int? I don't know. Maybe I can. No, that's 6 more digits every time. So maybe you would have something like. Okay, so you start at 1. Times I divided by I, or the other way around, maybe? I don't know. No. Something like that. Does that work? Is that the same as we had before? Nope. Maybe I'm off by 1. Last one. I'm just being lazy, honestly. Yeah. That's right, but it's just that this is going to be too slow for n as you go to whatever, right? I know that's for a given n, so okay, so how long would this take? It looks like it's timing out, and memory limit exceeded. Just not a big issue, but also kind of is. I just don't know how to do this. Q, but not good enough because I don't know how to do Q3 apparently, and 1,000 people got it. How does 1,000 people know the answer to this one? Am I just being dumb today? Maybe I am. Maybe I just gotta do this. I don't know if this is quite right, but maybe we just gotta YOLO inverse math. How? Last one. Power to -1 mod 10, right? Does that even work? Would this give me an error? Yeah, that's what I thought. Can I do like a mod 5, mod 2? Still not invertible, huh? Did I do the... I don't think this is right. I don't think I just got the parameters well. So that would be funny. Okay, well, I guess I don't need F. Just wanted to be... Well, all zeros is probably not right, so okay. Which one though? Oh, because is it 0 or something? Then I don't know how to do Q3, huh? For 25 minutes. I mean, it's fine. I mean, I'm gonna eat some waiting, but I mean, I feel like I am not knowing something, so that's okay, I suppose, in the sense that that means I'm gonna learn something. Maybe I could have done Q4 earlier if I had looked at it earlier, but not a huge deal. Yeah, I don't know. I mean, it's gonna be 0 eventually, so I don't even, so I don't know how to do it necessarily. Memory limit, oh, not even, huh? That's actually surprising, but I mean, yeah, I don't know. I was hoping to do some funky math with this one, but I mean, I'm not gonna get in 3 minutes if I didn't, you know. I don't get it. Maybe I need to reset, and I'm just not resetting correctly. I think what I was doing is right? Contribution. Am I though? Alright, let's see. Maybe I am doing it wrong and I didn't realize it. Okay, so 390, you add them, this is 2, this is 9, right? And then now, right? And then this is 2, say, and now this is 1, right? So then now you have this thing, which is just Pascal's triangle. I don't know how other way to look at Pascal's triangle. You do, right? The 9 contributes to here and also here. So there's a 9 here and 9 here. This is the classic 1, 2, 1. And that's after one iteration, right? So that means that, yeah, this is 1, 2, 1. This is 1, 1, 1, right? So this 1, 2, 1 minus also 1, 2, 1. I don't know. I don't. I mean, I can't think of it without Pascal's triangle, and I can't do n square Pascal's triangle, so I'm just really weird. I mean, yeah, I mean, it is Pascal's triangle, but I guess I'm just missing something obvious. Maybe I'm just really bad at math. That'll be funny if people just did it n square. Okay, it ended. Do I get a hint? Let's see. Let's look at UI. I mean, I was thinking of along those lines, but I just don't know how to do. I mean, I knew the Pascal's triangle immediately, but I don't. What does this do? Okay, so for given n, Yeah, I mean, we got this part. I don't know. People are saying a lot of things, but it don't actually say. I don't know what this is. This is some crazy talk. I mean, this looks like, honestly, an obfuscator, just trying to hide the fact that they're cheating or something. But I mean, I don't know. Maybe I just don't know enough math. It seems like a lot of people are just like cheating. Also, just like random code that doesn't make sense. But I guess this is just. I guess there's just a lot of hard-coded math on the on keeping track on 2s and 5s, which I guess I was and multiple inverse. I don't know. So we count they count the number of 2s and 5s on the thing, and then they divide it as well. Is that good enough? I guess I was thinking about that, but I mean, I didn't have this part in my head. But sorry, I'm just like kind of chatting with people on the Discords. I mean, and also like a lot of this code is probably like cheating code, so like it's, I don't know. I mean, I guess the idea I already had, but this is just such a silly problem. Like, I don't know. Now this is kind of cute, actually. Maybe that's a good idea. I don't know if I could figure this out, but all right, I mean, I get the idea. But I didn't really look at the code tightly, so maybe I can kind of figure this out. Okay, so that means that, oh, well, yeah, I mean, I don't know. I guess this was this one. I guess I'll just leave it up, but okay. So this idea I did was thinking of it, but I didn't really think about how to look it up. But maybe it wasn't that bad because there are only 10 possible entries for 2 times 5 possible for the last digits. Okay, so let's see, right? So okay, so yeah, I was actually thinking about this, but yeah. So what does this look like? Was it C choose K? What was this? But I just didn't think that. I thought maybe I was missing something more fundamental, honestly. Like I didn't want to grind it out, and also I spent all my time on Q4, which honestly I thought would be a little bit better. So okay, so you have this, which actually I thought it would be more predictable. I mean, this is actually Sierpinski's triangle, right? Something like that. So I mean, I spelled it really wrong though. Sierpinski's triangle. So okay, so this is just Sierpinski's triangle on mod 2, right? So I guess is that what this is doing? Oh yeah. Oh, there's actually something. And yeah, and honestly, as soon as if I had seen this, then this would actually be pretty obvious what mod 2 is. So then maybe we could have something like we got let's just do mod 2 n and k, then what is it? I actually don't remember the formula for it. Is it a factor? Maybe I'll Google it. On whether a cell is 0 or 1. I feel like there is like a. I'm looking at the Wikipedia article. There are multiple ways to generate this, but yeah, I don't know. But I don't know the formula actually. And Wikipedia is very slow on it. I mean, I could figure it out. Because this is 1, 2, 4, 8, 16, right? So then it's just subdivide. You probably could even do better than that by just generating this. Frankly, I think it's something on the bit. Right. So 1, 2. This is every other one. 1, 2, 1, 1, 2, 3, 1, 2, 3, 4. Actually, I don't know though. I guess he does, but actually, I don't know this one. Why do I know this one? And that's an interesting way of doing it, though. Maybe I don't know how to. Okay, let's put this on for now. Let's look at 5. Right? Is 5 any different? I mean, it's obviously it should be different, but is there anything we can exploit? There is some like Sierpinski-y thing to it because of the zeros, and then you have 3. So, I don't know how to. They just. I guess they just kind of really hard coded it, huh? Because basically it's just the states, right? So then it goes from well, they even cached it actually, but I don't know how. Okay, maybe I don't know how to do it this way. Maybe I was lying. Apparently I could have used the Lucas theorem, but I thought that would be too slow, honestly. But yeah, and this is maybe more similar a bit. And mod 5 is crazy. I don't know what the intended solution is, because I feel like these things are crazy people's solution, right? Like you're not really solving problems at this point. You just random knowledge. Maybe this is well, okay, this is just Lucas, which is also random knowledge. This isn't. It's just not a good problem. I mean, Q4 was fine, and then it just became a problem of who skips Q4 the fastest, or who skips Q3 the fastest to do Q4. But and this is a very bad problem, honestly, because there's no point. I don't know. I was hoping that we'd learn a little bit more, but I don't know that. I mean, I don't know that learning. It's just. I'm kind of annoyed at this problem. That's why I'm like trying to figure out what I want to do, because this is just silly. I mean, I'm not. Just to be clear, I'm not like making fun of these people's code. I'm saying that the fact that you need this is silly, right? Though I would also say writing all this code in 18 minutes is. I don't know if I believe that. I don't know. I don't know who this person is, so maybe they did. But maybe is it studied? I don't know. Maybe it's people. Maybe just some people know it. Maybe it's Googleable. But yeah, I guess I'll just do Lucas. I kind of was not doing. I didn't think it'll be fast enough. But yeah, during the contest. But and I thought that there would be I thought there'll be a more first principle solution, but I guess it's fine. Okay, fine. How did I write it? Right. So right. So you want and you need CRT. Okay. So how do I want to write it? Right. we want to calculate nk. Okay, so fine. So we want to calculate whatever, calc and choose I with a mod of, let's just say p2 is equal to this, p5 is equal to this, and then I don't know, do some magical things later. We're not going to be close yet. And then the idea of Lucas is going to be just n in base p, right? Yeah, n in base p. Okay, yeah. Okay, fine. Is it? Yeah, okay, fine. I think that's right. Right. So then for while n is greater than 0 and k is greater than 0, because otherwise if one of them is 0, doesn't matter. Then it's n mod p. Right, so the top, maybe bottom, is equal to k pod p, and then it is just t. Oh, I see. The way that they did it is with Lucas then, right? I thought that they did something more clever, but I guess so. I actually did know Lucas, but okay. It is what it is. I thought that there'll be, so then t choose p, right? So here that's why they had some stuff like that. I thought they did something a little bit smarter, but yeah. Okay, so n in range from 5, k in range of n, right? Then first p5 dot append to do, and then p5 dot append, the last array dot append, whatever, just be lazy, right? So math dot comp of n of k mod 5, right? Okay, so that's how they get the thing, right? I mean, I know that that's wrong. I just want to see the p5 part. Okay. So, yeah. I mean, I'm clearly missing one thing, but that's fine. It's this thing. Okay, right? And then now you could do the same for 2. And that's easier than, I guess this is easier than constructing the whatchamacallit, Stravinsky's triangle. So then now you have all, we multiply by, oh, I guess this is actually important. If p is equal to 5, then this is equal to p5 of tb, all times this mod p, right? Mod 5, I suppose, and then else is going to be a 2, so that's fine, right? Yeah, okay. So then now we need Chinese remainder theorem to get the rest. But even then, it is not that bad, right? I mean, okay. So here we can actually move this out, and also I destroyed this end by accident, so that is actually not great. Not that bad. And then CRT, I actually don't remember how to do CRT off my head. Let's see. I don't really have code written. I mean, I guess I could find it. Let me see if I could find it. Is there anything? Is there a Python library for CRT? Chinese remainder theorem? I guess I should have just done it. Doesn't seem like it. Other than some code I find in Python. Okay, fine. How do I do it? Let me see. I don't remember. Okay, so yeah. Maybe we can just code a lookup. Yes, you go to 5 times 2, is it? Right, and then for I in range of 2, for j in range of 5, then lookup of ij is you go to, I don't know, calc ij, right? Or crt ij, I guess. Can I just steal someone's code? It's not that interesting. This part is not that interesting, I think. I'm gonna steal someone's code. Let's see. Oh, they actually, I guess you can brute force this. Because there are only 10 things. But that's a little bit awkward. Yeah, I guess you can brute force this. That's actually pretty nice. Okay, fine. I did not need to know that. What I want is actually, yeah, for I in range of 10, then yeah, lookup of I mod 2, I mod 5 is equal to I. So then now, yeah, okay. So then left side, we just go right? And we can now do math a little bit dumber. And then look up of P. Oh man, this is terrible naming. Okay. X2, X5. Left multiplied by this. Also mod 10. I mean, you can make that a little bit more efficient, but that's fine. I think I just spend most of the time trying to figure out. Yeah, I mean it's this times what's it called? The input, right? S sub I plus 1, right? Yeah. Okay. I don't know if this is quite right. I mean, I think the idea is right. I just oh, it's not CRT anymore. It is. Oh, actually, you don't even need it anymore because we already did it. P2 is our bounds. Why? Tell me why. P2 TB. Why? Huh? Did I do this one wrong? 0 1 0 2. Right? Okay. Let's see. Should be. Yeah, I can't imagine it be that wrong. 0 1 1. Oh. I guess the other cases are 0. Yeah. I forget that. Yeah. Okay. If t is greater than b, then r is equal to 0. Else you have this thing. What are you feeding me? 0 1. Am I printing anything else? Where's this one? Oh, 1 1 is good. 0 1, right? Oh yeah. Did I do it in the wrong order? I did it in the wrong order, I guess. Well, technically, I did this one in the wrong order. 1 choose 0, 1 choose, or 0 choose 0, 0 choose, or 1 choose 0, 1 choose 1, right? Why do I have 0 1? Oh, where do? Oh no, this is normal. Whoops, I just had this. That's the part that I messed up. Okay, so that is nice, except for it's wrong. But it's nice until the wrong part. Why is that? Oh, because I always return true, so that is clearly not right. Okay, still not right, but that's okay. We can take a look at least these 2 examples. Zeros are definitely not what we expect. So yeah, let's see. It's added out lookup is wrong too. Okay, well. No, lookup looks rightish. Yeah, I mean, looks. I mean, maybe it's reversed, but I think it should be okay. Okay, so definitely something funky. It's because I started at 0. Okay, Larry. True, false, 2 and 6. Is that even right? We can't figure this out, right? So no, it's 4 and 8 and 1 and 1. So that's just very wrong, probably. And I just got lucky, maybe. So I have 1, 3, 3. That's okay. So you can see that here, at least that's good in that. Yeah, it should be 1, 3, 3 for that. So this is actually n minus 2. And we were very lucky, I suppose. Okay, 0, 0 is still wrong. 8, 4 is good though, right? Yeah, 4, 8. But 11, 11 is not quite what I expected. 1, 2, 1, 1, 2, 1. Right, so the left side is... let's see. What is the first digit? 1, 2, 1. 1, 2, 1 is right. So then the right side is going to be 1, 2, 1. On the on the left side should be 1, 1 of 3, 2 of 9, or 9 of 2, I suppose. So that's 18, 21. That's not right. Did I do something wrong on this one? Something's weird in this one. So then reverse is 2. That sounds right, actually. Would it look up? I mean, this is the expected answers are right, but something is really wrong here. That's why I'm like a little bit wonky. Why is this 9? Oh, this is 4. Okay. Oh no. 3 times or 3 plus 18 should be 1. So this should be a 1. I don't know why that is a 4. Lookup is 2. I guess the only thing that I didn't add is in case I have an off by 1. No, it's 18. Oh, I am dumb. Why did I have this? I think I just confused things. Okay, 1, 1, 4, 8. We're Gucci. Maybe I should have done it with Lucas. I did actually know it, but I didn't really think about how to implement it, honestly. So maybe I just kind of thought that was a little bit weird. And this may time out, I guess. Apparently. Oh, okay. Yeah, but yeah, I mean, I also thought it would be too slow, and 8 seconds honestly doesn't really disprove that. So I don't like. It's true, but also like I don't know. Well, it's a very sad. I mean, I don't know. Okay, I mean, sorry, I'm just like kind of think about like how could I have done things differently, and I guess, yeah, I mean, I don't. If you knew that, and I'm not picking on this person. I don't know who's cheating or who's not anymore. But if you knew this, then maybe you could have done this quicker. I don't know. I mean, you probably didn't need to construct this. You could have just written for loops, but. But actually, I mean, even with all this, I mean, this doesn't take that much pre-processing, I guess. Maybe I could optimize the other parts. The other parts maybe being this part, I suppose. Maybe this if statement, this, oh, and maybe this I could return because if maybe that could make sense actually. Let me see how much faster, slower, or whatever it is for this one. And you could maybe even do some math on the fact that you know, on adjacent ones it's a little bit like you could do math that way. So actually this actually saves it like half the time, right? So that's actually crazy. But thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, these explanations. Yeah, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.